In this video, we're learning about tangents. Now, this is a bit different to the trig tangents. This is a tangent. So tangent essentially is a line which just touches a curve, and it doesn't cut through it, it only touches it. So if I draw something like that, it is not a tangent, but something underneath like that is a tangent. So we'll be finding equations of tangents, and the reason that they care about this so much is that tangents actually tell you a lot about slope. If I have some weird curve, we've talked about zooming in on the curve to try and figure out what the slope is, but a more formal way to talk about that is, well, the slope of the curve is the same as the slope of the tangent at that point. So if you can draw a tangent and figure out the slope of that red line, that will also tell you the slope of the curve at that point. And that's why they care about it so much. But with actually calculating equations of tangents, we use this formula here, and you just chug through it. That's literally all you do. So we need to find a, f of a, and f dash of a. Those are the three bits we need to get our formula working. So a is just your x value here, it's 3. And if I want to work out f of a, that's f of 3. This is essentially the height of the curve. So in our case, that's 3 squared, which is 9. So that's f of a. So if you go and look at a graph of y equals x squared, you'll see that when we have x equals 3, y does equal 9. So that's sort of where we're going with that one. Next thing we need is f dash of a. So the first thing we'll work out is f dash of x. The derivative of x squared is 2x. So the 2 comes down out the front and the power drops. And then f dash of a is, well, it's f dash of 3, which is 2 times 3, which is 6. So this is the slope. So maybe if I want to write like x position there, y position there, so like the width and the height, and then the slope would be these 3 bits, what they mean. But basically, to get the equation of your tangent, it's y equals f dash of a times x take a plus f of a. And that's sort of the formula from the top there. Now, I'll really stress that you want your functions written like this. If I wrote it like y equals x squared, I want you to rewrite it to f of x equals x squared. Otherwise, it's going to get really confusing when you try and do this. All right, so essentially f dash of a is 6. So that's going to be 6x take 3 plus 9. And we expand out. So you're going to get 6x take 18 plus 9, which is going to give you 6x take 9. So that's sort of the equation of the tangent. Now let's check that this actually works. So if I graph y equals 6x take 9, you can see that blue line does sort of just touch the red line. There we go, you can see it a bit more clearly there. The blue line is just touching the red line. It does not cut through the red line. It just gets really close, touches it, and moves on. And if you look at the slope of the blue line and the red line at that point, you can see the slope is essentially just the same. And we actually know what the slope is. The slope is 6. The other thing that you sometimes do is find normals to curves. So if you've got a tangent is sort of like parallel to the curve, a normal will be perpendicular to the curve. And this can sometimes pop up in year 12 exams. So that's why I always make sure to show you normals, just in case. So it's all the same process as before. A was 3, f of a was 9, and f dash of a was 6. Because this is the same sort of question as before. I've just replaced the word tangent with normal. Basically, the equation looks like this. It's minus 1 over f dash of a out the front. X take a plus f of a. And that equation is also in your topic booklet up here. There it is. So basically, all that you change in the equation is that bit there. So let's just chug through it and see what we get. So minus 1 over 6, x take 3 plus 9. So I'm going to get minus a 6x take, probably that'll become plus a half plus 9. So minus a 6x plus 9.5. That's the equation of my normal. And let's see if that works. Minus a 6x plus 9.5 equals minus a 6x, make sure x is on the top, plus 9.5. And you can see that now, this always tricks me. That does not look like it's perpendicular, right? And that's because our window is zoomed weirdly. But if I sort of return it to what the zoom should look like, you'll see that it pretty much is. The angle between that blue line and that green line is a right angle. So be really careful with your windows, because sometimes your normal does not look like it's at a right angle.